Good evening, everyone. My name is Mansi Tripathi. I am TA for the course in my metal chemistry, and this is the week 5 of problem solving session. So I'll repeat what we do in these problem solving sessions. What we do is we take few exemplar problems that are relevant to the assignment as well as to the examination point of view. We try to solve those problems, and apart from that, in case of any doubt you guys are having in the classes as well as here in any of the problems, we'll try to solve all those things. So this is the main motive of this problem solving session. Okay, so I'll show some questions. I'll give you some time to solve those questions by yourself. Anyway, we're going to see the answer after that, so you can match with your problems. Okay, so we'll start with question number 1. So the question number 1 is the question regarding the log C versus pH diagram. Excuse me. It's regarding log C versus pH diagram. So here 5 points are given, 1, 2, 3, 4 and 5. So which of them denote the points where pH is equal to pKa for monoprotic acid system? So we are talking about monoprotic acid system. So what are these monoprotic acids? Like HA. So when this HA dissociates, what happens? It produces one proton because it is monoprotic and a conjugate base. Okay, we can write like this, like so that you can see like such denotations. So this is their association. So this is happening at some pKa. So what is pKa? This will be H plus AC and HAC. So out of all these points, where pH will be equal to pKa? So this is the question. So please try to remind yourself of what was taught in the class and then try to answer this question. You can draw all these diagrams by yourself. Sir has explained it, how to draw all these diagrams. You can draw it roughly. So please try to solve this question, then we'll see the solution in a minute. We'll see the solution now. So the solution for this question is point number 3, which is this point. How? So in this diagram, the green line which is coming, it is reduction of HAC. So that's why it's reducing with time. And this purple line is increment in AC negative. So the point where HAC is equal to AC is the point of where peak H is equal to pKa. The same is written over here also. Here HAC, activity of HAC is equal to activity of conjugate base. So that's why this point 3, this point is where pH is equal to pKa. Okay, when we draw like this point is pKa. We'll move towards next question. Which of the following condition given below are true for log C versus pH diagram in given in question number 1? So you have seen the diagram in question number 1. Okay, so When pH is less than pKa, log HA is equal to log AT minus log Ka minus pH. So all these things are from the diagram in this question. Please take a picture of this question or take a screenshot so that it can help you solve this question number 2. So I hope you have taken the screenshots. So this is the question number 2. Please try to solve this question. We'll see the solution now. So the solution is B, C and E. So when pH is equal to pKa, so we'll see this we have seen, right? Okay. Then when pH is less than pKa, then what happened? We have to write equation when pH is less than pKa. So we are talking about any of these points. Let's say we are talking about this point, or we'll talk about this point to cover this orange line as well. So here we have this H plus, we have this OH. So we are writing the equation that pH plus plus PHAC. Okay, then same equation we have for like PAC. Like this is log, this is in concentration in term of log na. So that's why we like log H plus, which is equal to pH plus also, pH also. So log H plus, we have log HAC. This line is log AC negative and this is log OH. So how do we write the equation for AC? So this is the solution. Log AC negative is equal to pH plus log Ka plus log AT. Okay, this is how we should write. Sir has explained this point properly in the class. So please refer to lectures to understand how do we write these equations. Same goes for this. Okay. Moving towards next question. While preparing the log C versus pH graph for a solution at equilibrium at ammonium at 10 raised to power minus 4, which having pKa 9.24, the correct linear equation for NH3 when pH is less than pKa is. So we are preparing this kind of diagram, log C versus pH. So this is saying 10 raised to power minus 4. So let's see, this line is minus 4. So this is our CT line, total concentration line. So please try to solve this question. It's a step-by-step process. So please follow all the steps and get to the answer. Okay, I'll wait for some time for you to get to the answer. Then I'll reveal the solution. We'll we'll see the answer now, then we will see how we are getting to the answer. So this is the solution for the question. Now we will see how we are getting to that. So ammonium can be written as the equation NH3 plus H. So NH3 total, what it will be? And when we talk about total NH3 species, then what it will be? Ammonium ion plus NH3. So that will be total 10 raised to power minus 4 molar. Alpha 1 is NH3 upon NH4 plus NH3. This is what we got. So just by writing all these things, when pH is less than pK means H plus is so much greater than Ka. So that's why we are ignoring this Ka here and we are getting to this equation. While solving the series of equations, what we are getting is PNH3 is equal to 13.24 minus pH. Coming to next question. A 500 ml water sample is collected, out of which 200 ml is titrated with 0.03 normal sulfuric acid to the end point of pH 4.5. Titration consumed 50 ml of sulfuric acid. The total alkalinity as CaCO3 is. This is the question in which you need to find out the alkalinity as CaCO3. So please try to solve this question. We will see the solution in a while. We will see the solution now. So the answer is 375 milligrams per liter. How we are getting to this? Just a second, something is wrong with my system. Yeah. So what is normality? Normality is weight in gram divided by equivalent weight, and this is the quantity we call as gram equivalent weight divided by volume of water or volume in which it is dissolved. So normality equation is N1V1 is equal to N2V2. So this such kind of questions are the most common that you will find for practical application. Okay. So acid and water sample. For normality of acid is given for sulfuric acid, right? And how much it is consumed? It is 50. Now we need to find the normality of the water sample and how much volume was water sample? 200. We got the normality. So weight in grams, volume in liter is equal to normality into equivalent weight, right? Okay. So equivalent weight of CaCO3 is 50. What is equivalent weight? Equivalent weight means molar weight divided by valency. What is the molar weight of CaCO3? 100. How? Like CaCO3 is there, right? 3 atoms are there. So 40 plus 12 plus 16 into 3, which gives us 100. So equivalent weight is 100. And when CaCO3 dissociates, what happened? It gives us Ca2 plus CO3 2 negative. So what is the valency? 2. That's why we got equivalent weight as 50. So just putting this thing in this equation, we got alkalinity as CaCO3 as 375 milligrams per liter. Okay. Moving forward to next question. Consider a closed system prepared with initial concentration of Na3PO4 1 molar, Na2HPO4 2 molar, this 3 molar, and all the forms of phosphoric acid or phosphorus we have here. So we need to find out the correct equation of total H. So what among these is the correct equation for total H? Please take some time and try to solve this question. We'll see the solution now. So HT is equal to, so this is the A and D is the solution for this question. So we have identified the species as sodium, hydrogen, hydrodium, H plus, OH minus, PO4 3 minus, HPO4 2 minus, H2PO4 minus, H3PO4, which will be the form of aqueous solution because it will be indissolved. Okay, the media is water. That's why we have H plus and OH negative. So what are the components which are required to make all of these species? Just Na plus, H plus, and PO4 3 minus. So these are the components which are enough. Their interaction is enough to uh, find out all these species. Like For example, if we want to make sodium, the sodium ion is enough. H plus is enough. How to make OH? H2O minus H plus. And the same goes for PO4 3 minus. What to do for HPO4 2 minus? Just adding these two, so on and so forth. So this is the basic technique by which we can make all of these given species by using just three components. So from this information we will make tableau. So all these species can be made by using just these three components. So we will write all these in the form of equations. Okay, a big equation. So by like H plus OH minus, what will be there? H plus OH minus HPO4. So we are trying to make H total, right? So that's why we will just add all of these. Okay, just by adding all of these we will get H plus, and by cutting in all we can get to this equation. Okay, so this is our equation. Now the second part is alpha naught is equal to H3PO4 and PO4 3 negative total, alpha 1 like that, alpha 2 and alpha 3. Kw is equal to deionization constant of water is equal to H plus and OH negative multiplied together. So that is what? 10 raised to power minus 14, right? Just putting all these values in this equation, we will get to this equation. So these are the two answers for your question. Coming to next question, consider a closed system prepared with initial concentration. We have the now closed system. Okay. Then the correct equation is, please try to find out the correct equation. We'll see the solution in a while. So our solution for this question, like in this question we have to give in terms of total H and total sodium ion. So option A and D are the correct options. So we will see how we are getting to this. So this has the correct option. So from question number 5, the previous question we have seen, that was also for the closed system. So we can, because all these compositions are same, so we can take from that question directly this equation. This is what you got in the previous question, right? So total what is HT? Because in this question we are getting all the concentrations, 2 molar, 3 molar, 4 molar, 1 molar and so on. So we can just use the equation that we got in question number 4 and we can put HT and we can calculate and we will get it as 20 molar. So similarly we got the same thing in question number 5 for sodium ion, right? I'll show you again. Just a second. This is for HT, and same we can get for sodium ion. Sodium ion, how we will get? I have shown you this table, right? So just multiply these coefficient 1, 3, 2, 1 to these things. Like how to write total sodium? This is concentration which is equal to activity, because why? Because this is a dilute solution. All these acid bases problems, since the concentration is very less, we will consider them as dilute solution. Plus 3 into Na3. Oh, I'm sorry, my mic was off, so I think I should repeat the part. So we were at question number 6. So we will consider a closed loop system. We had having the initial concentration of all these components which we found directly in question number 5, right? So in this question you have to do nothing. We have to just put all these concentration in the solution like I have shown here. So what is total HT? It Na2HPO4 plus 2 into NaH2PO4 plus 3 into H3PO4. So this is how we got total HT, right? So similarly, we will repeat these things for other ions. Like for sodium, so we will go to question number 5 and we can calculate the same thing for sodium ion, right? And on putting all these values in sodium ion, we will get HT and NAT. So this is your solution. Moving towards question number 7. For H3PO4, pKa1, pKa2, pKa3 is given. Then the correct order of the predominance of the species at pH 2, 5, 8, 11 and 13 is. Okay, which of these species will be predominant at all these pHs? So that we have to see. Please try to solve this question. We will see the solution for the question in a while. We'll see the solution for this question. So these are the species which will be prominent during respective pH ranges. So such kind of diagram can be made. See, this H3PO4 will dissociate as H plus H2PO4 negative. Then this will dissociate further as H plus and HPO4 2 negative. This may dissociate further, which will give us H plus PO4 3 negative. So these things happen at certain pH. Okay. So this is how this concentration will change. So by this diagram, we can know at what pH which one will be the dominant. This gives solution for this question. Moving towards next question. A solution prepared with initial concentration of NaHCO3 is 1 millimolar, NaC2CO3 is 2 millimolar. These are put in a closed system and system is allowed to equilibrate. pH is X now if the system is opened and allowed to equilibrate with the atmosphere. So first the system is closed, then the system is open. We need to solve this question by using Visual Mintic. I hope you have that installed because this has been running from the previous week as well. So please try to solve this question and please let me know the answer for the question what you have got. Then we will match it with the solution. So we'll see the step-by-step solution now. So according to the question, we have NaHCO3 as 1 millimolar and Na2CO3 is as 2 millimolar. So when we write total Na, then we will write 1 into NaHCO3 because it is 1 millimolar and 2 into Na2CO3. So this is what we got as 5 millimolar. Now we will write about H plus because in this we have H plus, that's why it's giving us 1, and here no H plus is there, that's why we are multiplying it by 0. So this is what we got 1. Similarly, we will get it for carbonate. Now we have to just feed all these values in Visual Mintic. Like component name we have to put, total concentration is 5, and similarly we need to add to the list. We will click here, add to the list 2 times, and we will add other things also. Okay, then we will click here to get species table. Upon clicking here, we will get all the results for the closed system. We will have carbonate, H plus and every other thing. We will run it and we will get the answers. Not talking about the open system. Now we have to click the gases menu and we have to specify. Sorry. Okay, click on the gases menu, then we have to specify. because the partial pressure of carbon dioxide is this much in the open system, this was the part of open system, that's we have partial pressure for carbon dioxide, and then we will put the partial pressure as 10 into 1,000,038 and click add. Okay. After doing this, we will again click on Tableau and we will get all these results for open system. So what is the difference between the pH in closed and open system? Is 10.34 minus 7.9. So why the pH reduced in open system? Because carbon dioxide is giving carbonic acid at this particular pH. Okay, so it is reducing the pH, it's suppressing the pH. That's why we are getting this difference in open and closed system. And most common systems are open system only. If you are talking about any natural system, it is open system only. So carbonic acid effect or carbon dioxide effect will always be there in an open system. Okay, so this is not question number 10, this will be question number 8. So in the question number 8, if the system is kept open in a room, now we are talking about a room, partial pressure of CO2 is this much and pH of the solution is 4.9. Then what is the value of A? So this is a kind of opposite question. Please follow this pattern which we got in question number 8 and please try to solve this question. We'll see the solution in a while. We'll see the solution for this last question now. So here now when we are specifying the gas, we have to put this pressure, okay, the one given in the question. So thus partial pressure of CO2 in the atmosphere can be written as 3.8 into 10 raised to power minus 4. Thus in the option which say enter the partial pressure, we will put x in place of x atm we will put, okay, so we will put different things here to get this pH. Let A is equal to partial pressure this much, okay, and B we have to enter the partial pressure at x atm. We have to use trial and error, we have to do multiple iteration to get the pH as 4.9. So these are the various iterations that we have tried to get to the solution. So first partial pressure was this, then we got then we got A and B like this. Then the second, when A is equal to 1, then A is equal to 2 minus 1 minus 2. So all the options which are given, we have tried all these things and we are getting the answer to the pH. So when we put 0, we got the solution. So the correct option is A, which is equal to 0. So this is the end. I hope you understood everything properly. In case of any doubt, you can ask me in the next session. So we'll close the session now. All the best.